So today we're gonna talk about what is a fractal. So imagine you are at this very nice landscape and there are quite some things happening here when you look at them all, and then suddenly you see, wow, these are all fractals. What? These are all fractals? Well, the idea of a fractal is kind of a self-similar shape across scales. So what does it mean is that we see these branches going up in branches and little branches going up in little branches. We also see that here branches go up in self-similar branches. Branches go up in self-similar branches. And these shapes also, you have little triangles here which go in bigger triangles, bigger triangles, bigger triangles. All these clouds are also like little round shapes, little round shape, little round shape, little round shape. And this lightning also little round shape, little round shape, little round shape. You're watching this nice view and you see all these fractal patterns, but then you also just realize that, well, my lungs are also have these fractal patterns. They also branch like this. Well, also my bloodstream goes through like fractal patterns filling up my whole body. And my brain also has some kind of fractal pattern of branching itself through space. So now that's weird, but well, the thing about a fractal is that it's this self-similarity across scales. So you see this branching pattern on this scale, and on this scale, and on this scale. And you can also see that for this mountain, as I discussed, on different scales you see self-similar shapes. And that's basically what a fractal is. But it's more than that, because also on a temporal scale, when you look at a heart rate, for example, there's also some fractal pattern in heart rate. So if you would zoom into this dynamics of the heart rate, you will see that at smaller scales the dynamics are also having kind of the self-similar shape as this one. And well, then smaller again, and there is quite some literature that actually having fractal dynamics in your own body is healthy compared to like random patterns or like very robust patterns. More like fractal kind of dynamics are very more often seen in healthy participants, in balance, for example, diabetes with glucose variation, those kind of stuff. And in the description I can send you some scientific paper about it. But fractals are self-similar across scale, but it's a bit more difficult than that, because there's still similarity across many different kind of dimensions of a fractal. So there's this angle, so the way these branches, in which angle they split and how thick they are, because this one's thicker here and then less thicker, less thicker, less thicker, less thicker, less thicker. And there's also about the density of the stuff itself and the material. But the angle and thickness are mostly signifying a fractal. And here you can see in this riverbank, for example, this not perfectly. So here's the angle deviates from the normal angle, and also the thickness is sometimes not really perfect. Also because I cannot draw perfectly on this thing. But the idea is there's some variations inside of these variables. And this way, also by seeing kind of using the similar structure, we can find very different shapes. For example, like here is the angle adjusted to the left, and here you can also see all different tree emerging, which goes all the way to the left. Well, this one is more geometrically different with like a different branching pattern as well as that one, giving a whole different shape. Well, this is more like a cactus, for example, it's very thick and then very thin and then very thin, but also with a limited size of branch. So you can create, well, almost infinite kind of fractal patterns using just this few variables, which is kind of insane, I think. So when we get to these lungs, so what do these fractals kind of do? So they also kind of fill the dimensions, because they are trying to, well, not trying to, but they are filling themselves across different scales. And this is also with your lungs, for example. You probably heard, or maybe heard, this example that your lungs are filling up football fields of their surface area, and that is because they have a fractal pattern, so they kind of grow infinitely, but they cannot grow infinitely in your body, filling up the full dimension as far as they can. But it would not be sufficient if they will be fully filled, because then the surface area, they will touch each other, and then this surface area of the lungs will decrease, so we could breathe less. So at some point they touch the bloodstream, and there they can exchange oxygen, having some kind of efficient shape for us to breathe on, because all these infinite surface area. So these fractals occur often with exchange with other media, exchanging energy with the environment, so sustaining some kind of their own structure while exchanging kind of energy with the outer environment. Another thing I would like to discuss is the way that fractals grow, because if you might have a very small tree, and the tree comes thicker, but it comes thicker in its branch, but then also in its branch and also expands to there. So it grows on all scales. So now it becomes longer and more branching, and then a little bit skip, but it's maybe not too much of a skip, because they will become thicker and you will get more branches. So at the end, these trees get very large and big because they grow on all scales at the same time. So this is kind of interesting and difficult to comprehend, because we are usually thinking at one scale or one focus, but this happens in a fractal. It happens on all scales at the same time. So in this video we did not really talk about how do these fractals come about, how do they exist in our world, but there are many thoughts and theories as well about efficient energy exchange. As you can see, these branches in these lungs, for example, they kind of grow where there is space available for them, finding some surface area with the environment, just as the tree does. It finds a space to live while having as multiple leaves as it can to surface with the environment to get oxygen. But it's kind of weird to assign those things to trees, because we also see this in rivers, for example. They don't really try, but they just emerge to be a fractal. But you can also see this in cracks, cracks of rocks or ground, for example. When things crack, they kind of get these fractal pattern through expanding of the space, so then a fractal kind of emerges from the space, filling, kind of getting that's more than a dimension then, so then you get this fractal shape within a higher dimension, 1.2 or something. This was too much for this video, sorry for that. I will make new videos for that, so about that, maybe they're already here in this list of different videos. But for now I want to thank you for watching, and you need to read more in the descriptions, and there are also more videos which I would recommend to watch, also not made by me. Thank you.